In this video, I will discuss about 74139 IC 224 decoder. 74139 is an integrated chip which consists of two or dual 224 decoders. Already we have studied in my previous lecture, that is 224 decoder. This 74139 is an integrated chip. Inbuilt, it consists of two sets of 224 decoder. It has 16 pins. Each 224 decoder, as I said, it consists of dual 224 decoder. Each 224 decoder has two input pins, one active low enable pin and four active low output pins. Here we can observe that, as I said, 74139 consists of dual 224 decoder. So here this part is, this is one 224 decoder, this is another 224 decoder. Here 1A, 1B are the inputs. These are inputs. So this is active low enable input. This is active low enable input. Similarly, we have four active low outputs. These are four active low outputs. Similarly, in another 224 decoder, we have these two are inputs or select lines. So this is 2G dash is another active low enable input. Here again we have active low outputs. So here active low enable input means when 1G dash value is 0, this 224 decoder is active. That is, when it is 0, as here we have a bubble, this bubble indicates it will take this 0 as invert. So when you give 0, it will take it as 1. In that case, this 224 decoder is active. If we give 1 here, then it will take it as 0. So this 224 decoder will be inactive. So to make this 224 decoder active, this 1G dash line should be always 0. Here we have active low outputs. Active low outputs means at any time any one of the output line is 0, rest all lines are 1. As we seen in 224 decoder of my previous video, here any one of the output line was 1, rest all are 0, because that was active high outputs. Here we have active low outputs, therefore any one of the input line is 0, rest all are 1. Similarly, with respect to this 224 decoder. Now let me write the function table of this 224 decoder. So now in general, in both the cases, we have A and B are the inputs. G dash is the active low enable input. Now let me write that. So this is enable input, that is G dash. We have B input and we have A input. Similarly, we have four active low outputs, that is Y0, Y1, Y2, Y3. Let me write Y0, Y1, Y2, Y3. So here these three are inputs and these are outputs. So as I said, the enable input, it is active low enable input. This is active only when input 1G dash is 0. So if 1G dash line or G dash line is 1, irrespective of A and B input, that is don't care, in that case all the outputs will be 1. It is 1 because the output lines are active low. So this is 1, the complement of this will be 0. So it is called active low outputs. So when G dash line is 0, so this 224 decoder will be active. So now we have to check the different possibility input values. That is, with respect to A and B, we have two inputs, four possible outputs. So when input is B is 0, A is 0, in that case B is 0, A is 0, Y0 line is 0, rest all lines are 1. As I said, in 2 to 4 decoder, the outputs are active low anytime any one of the line is 0, rest all are 1. That is, when A and B are 0 0, then Y naught line is high, rest low, then all the lines will be high. Similarly, this should be 0. Here we have 0, say 1. In that case, Y1 line is 0, rest all are 1. Like this. Similarly, this will be 0 when B is 1 and A is 0, then it is 2, which is Y2 line is 0, rest all are 1, like this. Similarly, when it is 1 and 1, Y3 line is 0, rest all are 1. So this is the function table of 2 to 4 74139 decoder. So in some textbook, instead of 0, they will use the variable L, which indicates 0, and instead of 1, they may use the variable H, which indicates high. Now let me write the output equations. So while writing output equations, we have to concentrate on output column where there is 0, because it is active low outputs. So we have to concentrate on 0. Let me write the output equation for Y naught. So here I can say Y naught is equal to, so for this Y naught, here we have 0. So here we have 0. The corresponding inputs are B is 0 and A is 0. So here we have to write it as B bar and A bar, that is B bar and A bar. As I said, these are active low outputs. It should be complement like this. So Y naught line is A bar B bar complement. Similarly, let me write Y1. Y1 is equal to, so Y1, in Y1 we have 0 here. So corresponding inputs are B is 0, A is 1. B is 0 means B bar A complement. B bar A complement. This complement because active low outputs. Similarly, we have Y2. Y2 is equal to, here we have 0. Corresponding inputs are 1, 0. That is B A bar. That is B A bar complement. Similarly, Y3 output equation is, here we have 0. Corresponding inputs are B is 1, A is 1. That is BA or AB complement. So these are the output equations. Now with the help of these output equations, let me draw the circuit diagram. So now according to this logic symbol, we have 1A, 1B, 1G dash. So let this be 1G dash, 1A input, 1B input, and the outputs here are 1 Y0, 1 Y1, 1 Y2, 1 Y3 active low outputs. So to active low outputs, we should use the bubble here. This will become NAND gate. This is 1 Y0. This is another NAND gate, 1 Y1. This is another NAND gate, 1 Y2. So this is 1 Y3. Similarly, with respect to another 2 to 4 decoder, this will be 2G dash. This is 2A, 2B input, and these are active low outputs. This is 2Y0, 2Y1, we have 2Y2, we have 2Y3. So now let me implement this. We have Y0 is equal to B bar, A bar, whole bar. So here I can say B bar, A bar. So here we have 1A, here we'll get A bar. Here we have 1B, here we'll get B bar. So for this, first the active low input signal should be connected to all the NAND gates. So this output should be connected to all the gates. Let me connect this to all the gates. So according to this equation, we have Y0 is equal to B bar, A bar. So we have B bar, A bar. This is A bar. It should be connected to this gate, and we have B bar here. So this is A bar, this is A bar, and another input is B bar. This is B bar. So here we can say, see that A bar, B bar, because of this not complement we have bar, that is nothing but Y naught. So Y naught is equal to A bar B bar complement. Similarly, here we have Y1 is equal to B bar A complement, that is B bar and A input should be connected to this NAND gate, B bar and A. So here it is B bar, this is B bar. Let me use another color. So this is B bar here, it is connected here, and we have B bar A. So here we have A bar, again complement of this is A. So I can connect A from here. So the output of this is, we have B bar, another input is A, this is complement. Similarly, for Y2 we have B A bar, that is B A bar. So we have, this is A bar line, this is A bar line. So let me take A bar from here. This A bar is connected to here, and we have B. So here B signal is available. Let me connect this B here. So output here is A bar B complement. So we have A bar B complement. Next input is AB bar, that is AB. Let me connect A and B. So this is B line, this is B line, and here we have, this is A line, this is A line. The output of this is B A whole bar. So this is with the circuit diagram with respect to first 2 to 4 decoder. Similarly, the same thing will be appeared here. Let me draw the same thing. So here this active low output should be connected to all the NAND gates. Let me connect this to all the NAND gates as one of the input, then only the circuit is active. So here we have A bar B bar whole bar, that is this is A bar. Here we have B bar. Let me connect A bar. This is A bar, and here we have B bar. So here output is A bar B bar whole bar. So here we have B bar A. So this is B bar. We have B bar, and here we have A. This is B bar A whole bar. Next we have A bar B whole bar, that is A bar signal is available here. This is A bar, and we have B is here. So this is A bar B whole bar. Next we have AB, that is one signal B, this is B signal, and here we have A signal, that is B A whole bar. So this is the complete circuit diagram of 74139 dual 2 to 4 decoder. Now let me verify the result. That is, as we know here, when the input enable pin is 1, so as I said here, if enable pin is 1 here, here the output will be 0. So this output will be given to NOT gate. Now let me verify the circuit diagram with the given input. So according to this function table, as I said, if enable pin is 1, that is if this enable pin is 1, then output of this is 0. So this 0 is applied to all the NAND gates. As we know, if any one of the input of the NAND gate is 0, definitely the output will be 1. So as I said here, all the outputs will be 1, irrespective of input values. Therefore, this gate should be always 0. That is active low input we supposed to use. Now let me consider A and B equal to 0, 0. So as I said, if A is equal to 0 and B is equal to 0, here we can see that A bar will become 1 and here B bar will become 1. Complement of this, that is 1 dot 1 is 1, complement of this, it will be 0. So in this case, so when B is equal to 0, it will be 1 and A is 0 complement, which is nothing but 0 complement, which is equal to 1. Similarly, here we can see that when A bar B, that is A bar will be 1 dot 0 complement, which is equal to 1. So B A bar, that is 0 dot 0, which is nothing but 0 bar, which is equal to 1. So according to this function table, when A is 0, B is 0, Y0 is 0, Y1 is 1, Y2 is 1, Y3 is 1. So here we got the same thing, that is Y0 is 0, Y1 is 1, Y2 is 1, Y3 is 1. So like that it will work for all any possible inputs of A and B. Thank you for watching.